Hi, today we'll go through an example of structure analysis using the method of sections. This type of structure can be solved through different methods. So method of join, also method of power notation, or mathematically, mainly using trigonometry. And this method, the method of section, is particularly useful when it is required only to determine the forces in a few members of the truss, like this one. So we ask in this question to find member CD, CM, and LM plus DM, and it should also be closer to each other, so to use the method of section. So the section, as you can see in AA and BB, are passing through the truss to cut the member whose forces are to be determined. So this imaginary section divided the truss into two parts, each of which is in equilibrium under the action of the external forces. So in this example, the W's is the external forces, and the internal forces of the cut members, which we denoted as F. You'll see it in the solution. So in general, these external and internal forces are not concurrent, i.e. they are not intersecting through the same point. So that means the sum of vertical forces equals 0, and the sum of horizontal forces equals 0. Also the sum of moment equals 0. And as you can see, we have two sections here, AA and BB, because we have been asked to solve for 4 members. So for the first 3 we can use the section AA, but for the last one, DM, we have to use BB. So we are allowed to use only solve only 3 members with one section. So by observation, before we go to the solution, we have to see if we can find the reaction. So because we have the external forces, W's here, we have 2 W's here, and we have one here will be 3, 4, 5, 6, 7. So we have 7 external forces downwards. That means we can divide these 7 between the reactions. So we can say reaction B is 3.5 W, and reaction A also 3.5 W. So this step will help us to carry on with the solution. And the height is y, and the distance is equally these x's. Yeah, you can see it. All these x's is the distance between the joint and the member. So for the first one, the first section, we have to find force 1, force 2, and force 3. This is the cut member. So here we said the sum of vertical forces, shall we call it the sum of call it FV, vertical forces equals 0. So that means we have reaction RA acting upwards, this one, and we have W acting downwards, but also we have to take with this the vertical component of force 2. We add it to W to be equal with RA. So what we can say here, F2 cosine, because we need the vertical component, cosine alpha plus W, that will give us RA. Okay, so we know that RA is 3.5 W, so we can say F2 equal 2.5 W over cosine alpha. And because we don't know alpha, so we can write the cosine alpha in terms of the members, so the height and the the adjacent and the opposite. So we can say it like, we can write it like this: 2.5. The square root of our height is y square, plus our horizontal is x square, all this over y, and we have w, don't forget the w. So that will be our F2. So let's go for F3 before we go to F1. For F3, we can say that the sum of moment equals 0. Yeah? So for F3 we have false, acting this way, and we have distance. Okay, and also for R we have false and distance. So this one, the F3 could be because the horizon vertical distance could be anti-clockwise, and this could be direction clockwise. So for F3, and the reason that we decided here to say that F1 is compression this way, acting this way, and F2 is tension, F3 is tension. This is just a guessing by observation. So if the truss is not really complicated, we can guess. But if we guess wrongly, that's okay, no problem, because when we solve it, if we get a negative number, that means our guess was wrong, so we have to reverse it. If we get positive number, that means okay. If we get, say, for this one positive number for F1, that means our guess was right. It was in tension, in compression, not in tension. Yeah. So the sum of moment equals 0. So that means F3, the force F3 multiplied by the distance y, our vertical distance, that is equal to the reaction, which is 3.5 W times the distance is x. Okay, distance is x. Okay, so that will give us F3 equal 3.5 x over y W. So this is our F3. And because F1 and F2 are passing through point C, so we can take a moment for these two, but we can apply the sum of forces. So what we can say that the sum of horizontal forces equals 0. Okay, so that means F1, because it's horizontally, equal F3, and the horizontal component of F2, so that will become plus F2 sine alpha. Okay, we are saying here the horizontal component equal each other, so the sum of forces, horizontal forces, equal each other. That is equal, so do some maths, 3.5 x over y between bracket W, our forces, plus, make a bracket, square bracket, we have 2.5 the square root of y square plus x square over y, so that's also times W, which is the sine, x over the square root again of y square plus x square. So that will be, so this will cancel, so we'll have 2.5 x over y plus 3.5 x over y W, both of them W, that will give us 6 x over y w. So that is all what we need. So this is f1. So we found f1, f3 and f2 in the beginning. So for the second question, we go back to the figure number 3. The second question, we have the cut BB, as you can see here. So we have been asked to find only force F4, and we said it is in compression. This is just a guess. We'll see now whether we are right or wrong. So what we can do for this one, also we say the sum of say force FV for vertical forces that's equal 0. So that means F4 equal reaction A minus W minus W. Why? Because if you can see here, we have 2W here. Reaction going up, W going down, another W going down. So that means F4 equal the reaction A W minus W. That will give us F4 equal, and we know that reaction A is 3.5 W minus W minus W. That will give us 1.5, and it is positive. That means our guess was right. It was in compression. So this is the way that you solve for member forces through the section method. So first you make a section for 3 forces as we did for AA to find CD, CM, LM, and another section to find DM. And by observation we find the two reaction, the sum of forces downwards. We divide it by the two reaction, will give us 3.5 W. So, and here we guess the direction of our forces. So the cutting member, we said F1 compression, F2 tension, F3 tension, and it was right when we found them positive. And again here we said F4 is in compression, and it was also we got it also positive. That means it was right as well. If we got it negative, that means our guess was wrong, so we change it. We say it was in compression, not in tension. Hopefully that is useful for you to solve for this type of structural analysis using the section method. Thank you for watching.